We were discussing about sets and we have covered various concepts, and now we were discussing the question answers and the examples. So this was the example which we were discussing. Write the solution set of the equation x square plus x minus 2. And as I suggested that the solution is x minus 1, x plus 2. If you factorize it, it will come to 1 comma minus 2. And the set will be written or can be written in the form of this braces, then 1 comma minus 2 and braces n. Now we come to the second example where x is such that x is a positive integer. So x needs to be a positive integer and x square is less than 40. How we can get x square less than 40? 1. 1 square is, yes, less than 40. Then 2, then 3, then 4, 5 5 is 25, 6 is 36, 7 7 is 49. So we cannot go beyond 6. We have to stick, or we have to limit ourselves to this answer, which is 1 2 3 4 5 6. And how we are going to write it? Braces 1 comma 2 comma 3 comma 4 comma 5 comma 6. Another question is, this is a set 1 4 9 16 25 dot dot dot. I'll tell you what this dot 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 is, but let me ask you a question. Is this the best way that you write x such that x is the square of the natural number? You take any natural number, say 1 2 3 4 5, square is like this. But always the English like language is ambiguous. Sometimes you speak something else, I speak something else. Both may have same meaning, but other may understand in a different way. So is there any alternative way or mathematical way? Yes, we do have. X colon x is equal to n square, where n belongs to capital N. Now x belongs to this n belongs to natural number. This is correct. And x is equal to n square. So every number will be a square of this natural number. Right? This is the better way. And we are going to adopt this in the later sessions also. So we need to write this particular set in the set builder form. So as you can see, we are moving from 1 to 6, and these numbers, which are the denominators, they are one more than the numerator. So if this is n, this obviously is going to be 1 plus 1. So we can write this in the set builder form. X is such that x is equal to n by n plus 1. And n plus 1, we need to restrict ourselves, or this n, from 1 to 6. 1 and 6 are inclusive. So what we have done, n is a natural number which is in between 1 and 6. This is how we are going to answer this. We have one more question, which is example 5. Now we need to match these. How we are going to match this? See, this is PRINCAL. This is, if we come to D, this is the letter of the word. X is the letter of the word principal. Yeah, this is correct, because we have P duplication, I duplication, and we didn't use it. And this strongly relates to this particular form. 0. So this is x plus 1 is equal to 1, so x equal to 0. So this matches exactly. Second matches with C. 1 2 3 6 9 18. We are looking at third. These are the numbers, as we can see, they all divide 18. So x, and they are all positive. So we can write it, x is such that x is a positive integer and is a divisor of 18. So this is correct. We can match this. 3 comma minus 3. And as we see, this b, x is such that x is an integer. X square minus 9 is equal to 0. So this is correct. Now we come to empty set. Tell me, can you count the number of students in your class? You will answer yes. Why not? But if I say, count any person of your class that also studies in class 10th, will you be able to count? Or tell me, if I insist you know, tell me one or number of members who studies with you and who also studies in class 2nd of your school. That will be an empty set. There will be no combination. You will tell me, sir, this is not possible. I can't find any person who is in 10th and 11th simultaneously. This kind of set where you don't get a single element, there is no element at all. These sets are called as empty set. So we'll define it first. A set which does not contain any element is called the empty set or the null set or the void set. So if I said void set, if I told null set, or if I uttered empty set, all these three are exactly equal, right? So how we are going to represent it? Empty set, we can represent it using phi or these braces, empty braces, nothing inside, nothing inside. Okay, so this is how we are going to make this. This is the empty set. Let us take some example. Any number, any natural number 1 between 1 and 2. Is it possible for you to find any number between 1 and 2? 1 is a natural number, and after that we have 2 as a natural number. So there are no numbers in between this. So this A will be an empty set. X is equal to x square minus 2, where x is a rational number. You cannot find any number which is a rational number, x square equal to 2, and x, any value which is the rational number which is squared and it gives rise to 2. It is not possible. So it's an empty set. The other is x is an even prime number greater than 2. X is an even prime number greater than 2. Can you find any even prime number greater than 2? T is the only one which we have. E2 is the only prime number which is even, right? So again, the answer boils down to the empty, null or void set. X square is equal to 4. Okay, you will say okay, I can give you an answer as 2. This is correct. But if I add x is odd, then there will be no answer. There will be an empty set. So this is how we do it. We understand it. Now we have finite and infinite set. Finite set, let me first tell you. 1, 2, 3, 4, 5, you can count it. So let me count it using n. And this is a A set. Let me put it inside a bracket. A and bracket A. So the general form is n bracket s. If you can count it, if this n is some number, you say it is a finite. Otherwise, it is infinite. See in this set, how many numbers are there? 5. n equal to 5. How many alphabets are there? 6. Men living presently in different parts of the world, that will be very cumbersome, but you can count it. You can count it. So I cannot say that these are the numbers which are uncountable. So we have a finite number. This is non-empty finite set. So by definition of the book, the set which is empty or consists of definite number of elements is called finite. Otherwise it is infinite. So if we have W as a set and we say it corresponds to the days of the week, we say W is finite. Again, S is the set of solution of equation x square minus 16 is equal to 0, we say S is finite. But if I say this is my line, please try to count the number of points in this line. Will you be able to? You will not be able to find or calculate the points here because these are infinite. These are infinite. How we are going to represent, as I suggested you, these braces and nothing inside. Okay. So one more thing. Tell me how many numbers you know. You'll say infinite. I can't count it. So how you're going to present it in the mathematical form? You will use these 3 dots. 1, 2, 3, dot, 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 dot. Okay. If I say you, I want the set as an integer. So this dot dot can be extended on the left side also, because on the left hand side also you have numbers. So dot 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 minus 3 to dot 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 left hand side, 3 to dot dot dot. So there are 3 dot dot dots. Okay. So all infinite sets cannot be described in the roster form. For instance, just take an example of real numbers that cannot be described in this form because the element of this set do not follow any particular pattern. Can you find out any pattern? No, you cannot. Okay, let us solve this example. First is state which of the following sets are finite or infinite. X minus 2, x minus 1 is equal to 0. So you have a finite answer 1 and 2. So you can write this set 1, 2. This is a finite set. Then x is such that x belongs to n and x square is equal to 40. Again, you can say that answer is 2. It is a finite set. 2x minus 1 equal to 0. X will be equal to half. But x should belong to a natural number. And half, that is 0.5, is not a natural number. Hence, this third one will be empty, but still it is finite. Please understand, it is empty, but still it is finite. What about x is such that x belongs to capital N and x is a prime? X belongs to N and x is a prime. Again, there are plenty of numbers which are prime numbers. You can go up to dot 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 and infinitely. You can go up to the extent. If you say this is my last number, I'll add a few more and I'll tell, okay, these are the numbers. So it is infinite series. It is not going to stop at all. That is why this is an infinite set. Right? Let us come down to this fifth one. X is such that x belongs to capital N and x is odd. Can you tell me what is the answer? What will be your discussion point? The answer would be, it is again an infinite number. If you say odd, 1, 3, 5, dot dot dot, and it goes up to infinite. We cannot stop here. Please understand, we will not be able to stop at all. This is true with the even numbers also. 2, 0, 2, 4, and it goes up to infinite. So these are infinite sets. These two are, I will categorize in the form of infinite, but these three, though this third one is 5, but still we'll say this is an finite set. So we'll stop today here and we'll be taking this next discussion, which is the equal set. Till then, thank you so much and take care of yourself.